Welcome to the on-demand library here at Tamnoon. This video you're about to watch is from a demo that was presented live at one of our demo festivals. What that means is this was recorded sometime in mid 2025, and so it was a live event, which means two things. One, people messed up a little bit. It was live, which is totally okay. It was a live event. And two, it means that things have changed since that took place. And so companies are constantly putting out new features. In fact, I think even one of the presentations today said, we're going to put new stuff out next week. I wish this was next week. And so if you want an updated version of that solution to see what's changed, please do one of two things. Either reach out to them directly. You can find their website on the page below, or you can request a demo from Tamnoon, and we'll make sure you get in touch with the right individuals. We work closely with them on numerous scenarios. And last but not least, if you have any questions about Tamnoon, we usually work with and partner with these companies that you've seen here today. We sit on top of most of the solutions to help you actually remediate the things that are found by these different detection tools. And so if you need help with understanding where Tamnoon really shines on the remediation side of the house, feel free to reach out to us for a demo by clicking the demo button on the top right of your screen. Of course, if you have any questions, don't hesitate to reach out or visit tamnoon.io for more help and more information. Thanks.
Wanted to add around.
Whoa, what is that? Oh, what a scared the bejesus out of me. All right, we are going to let everyone get in here for just a second before we get started. Everyone knows the drill. Join the next session, then we get started. Righty, perfect. Everyone is now in. Awesome. Please give a warm welcome to our final session of the day. Actually, it's really hard to go first. It's hard to go last. Well, so really warm welcome to Maor. He's like the Oprah of CDR. You get runtime, you get runtime, everyone gets runtime. And we're going to let Maor come on for this festival and get started here. Maor, I'm going to pull you on stage. And while we do that, James, you know the drill, my friend. What's something you love about Stream?
I think the thing that comes immediately to mind is how like a lot of people have tried to use the digital twin language now. When Stream is probably the only one that is actually doing that of the people that I've seen use the language. So if you're looking for true digital twin technology.
Ooh.
Yeah.
Love it. Maor, it's your time to shine, my friend. You want to go ahead and share your screen and not do an infinity mirror, and we will make sure that you got it up and going, and then we'll dip out of here.
Absolutely. Thank you, Joseph. Thank you, James. So hi, my name is Maor Idan. I lead product marketing at Stream.Security. And at Stream, we understand how challenging the cloud is for security operation teams. And basically, we see two main factors that makes the cloud so complicated. First, obviously, there are simply too many changes in the cloud environment, whether it's done legitimately by DevOps or maliciously by a threat actor. And second, every change in the cloud is unpredictable. It's very hard to know how changes in network, identity, workloads impact the cloud attack surface. And I think a good example is when you change a security group, the only event that you're going to get from your cloud service provider is a security group changed, not what is the downstream impact, which assets are impacted, and what it looks like. And if you think about it, other than obviously Kubernetes visibility, the need for runtime CDR arrived from the fact that posture solutions are static. You need to scan, you need to wait a couple of hours until you get the result, only to know what your environment looks like. And for vulnerability management, in a way, that's fine. But if you think about the live incident, that's obviously a gap. And if you try to stitch together runtime data, which is obviously real time, and static posture, you're kind of risking in acting with a false sense of security. And the state that you see your cloud is not up to date. And at Stream, as James mentioned, we solved it from the core with our unique cloud twin technology. Stream built the first and actually the only simulation that models the cloud environment in real time. And we're talking about identity, network, Kubernetes workload, and actual behavior. And you don't need to scan your environment for that. Now, every event, every change is being processed on the spot. And then you can also see the downstream impact. And on top, obviously, we're going to add the runtime and the Kubernetes visibility for the workload, but we also integrate with other agents or even EDRs in some cases, because we see it's very common among our enterprise customers that they want to keep their EDR, but still overcome the cloud native challenge. And I think it's a good time to share my screen. So let me do it real quick. And here we go. Let me know when you can see it. Perfect.
Got it. Yep.
This is what the cloud twin looks like under the hood. And before I'll go into detections, I just want to give you a glimpse of what the platform looks like and how it operates. Here, I see a live map of everything that happens in my cloud environment, and it is cross-cloud, meaning if you have both Azure, GCP, and or AWS, all three of them, it's all combined under a unified graph, and you can see all the dependencies between them, whether it's cross-account, cross-VPC, cross availability zone, cross everything basically. And then once we build this map, every event, every log that you consume from your cloud service provider, Stream will take it and will ingest it into the map. So instead of just accumulating a lot of raw logs, which is very hard to understand what to do with them, Stream takes each log and ingests it into the cloud twin and makes a live representation of what the cloud environment looks like. Now, if you think about this real-time capability, it's basically twofold. First, obviously, you have a live state of what your cloud environment looks like. But second, you can actually understand the impact of every event going into your system, because every event is ingested to the model is being updated accordingly, and then you can understand by the kind of the delta between the two, what is the actual impact of it. Let me show what it looks like in terms of the actual events. These are the events that we consume through our logs, audit logs, Kubernetes logs, flow logs. Every log that can be streamed into our platform is being streamed. We gather it, and then we analyze every event with its downstream impact. So I have an event that created a new connection, a new connectivity between two different assets, and these events are not necessarily related to an attack. We just start from the ground up with the right foundations. And then, because we understand the impact of every change and every event that happens in the cloud environment, we are able to concurrently create different attack storylines. And then once we detect that something is suspicious, we know to automatically correlate everything. And we don't need to do it in hindsight because everything happens in real time. So I can just take an event. Again, every event is going to be, do it again. Every event is automatically ingested, and we can reveal its downstream impact. I can see what was the change, what was the impact. I see an internet exposure, and like think about it. If you use a different posture tool, you'll have to run a new scan to know that this change led to internet exposure. I can see all the risks, everything here, just click of a button. And in a way, it's a much more efficient way to manage your cloud logs because at the core of the cloud logs, they lack the context. They show you what happens, but not the so what, not the downstream impact. And that's how we built the kind of backend of our platform. Now it's a good time to go and see some detections. That's why we are here for. So let's take a detection. Stream detected that there was an anomaly. And again, this anomaly could derive from our agentless approach, where we analyze the logs, from our Kubernetes sensor, where we can see it on the actual workload, or even through an integration like the EDR that I mentioned earlier. First, Stream shows you what are the signals that made this alert suspicious or this behavior suspicious, because Stream is going to baseline the behavior. We know to map all the different configuration changes and activities and how we expect the different assets in the cloud environment to communicate. And then we start to flag for anomalies. So here we're gonna see, here is the first thing we see, that there was anomalous data store connectivity. This is the first time that this EC2 instance connected to a data store. Again, something that we see both on the posture and on the activity level. We also see anomalous outbound connection. This is the first time that these IP addresses communicated with this instance. And we see spike in the traffic volume. This is definitely something I want to keep investigate. So I'll go ahead and start the investigation process. On this screen, I see visually the entire chain of events that happened on these assets, again, both on the activity level and on the configuration level. If you think about the MITRE ATT&CK framework, when you start an attack and you need to understand the overall story of how the attacker started it, they're going to start with initial access, discovery, lateral movement. All these things mostly happen in the cloud layer. You can just connect to your console, you can change the configuration, modify security group, assume role, and these operations, these activities are part of the attack, not just what happens on the actual exploitation. So Stream shows you everything you need to know in order to investigate this alert. So we start with the anomalous network activity that was detected on the EC2 instance. This is what triggered the alert. Then I see that a CrowdStrike instance also triggered an alert on the same instance for machine learning process behavior. So obviously seems much more suspicious because I see two detections from the same on the same asset. Then I see a suspicious canary activity on the same instance. Now, let me take a step back and explain what this canary does. So since Stream understands the entire posture, we can also understand exposure. We know what assets are at risk, similar to a CNAP tool. But since we know it in real time, we can act upon it. And we can say, okay, I see this instance is exposed to the internet. I know DevOps is going to take them, I don't know, like 2 weeks, 2 months to remediate it. In the meantime, Stream will automatically suggest to deploy a canary, a decoy asset on this instance. So if this instance is being exploited, then Stream can detect it and do 2 things. First, we can slow down the attacker because we send them to a sandbox environment and it takes them much more time to understand what they're doing. We hold a list of different keys for different environments that looks very tempting for them. And second, we also strengthen the detection fidelity because we build a baseline and we know how the different applications operate. And because we understand that, we know that no solution or no process should touch this canary asset. And again, we baseline it. So if there is any backup activity, it's also something we can flag and kind of eliminate it from generating a false positive. Going backwards in time and understanding what else happened, I see that this identity was trying to get API calls for the AWS security token service. And I see that there was a DynamoDB get item action on a database called billing. So I have an asset who is trying to access my billing database, my DynamoDB database, and they're trying to exfiltrate data from this instance. The operation that started the entire attack is a modified network interface attribute, meaning there was a user named UriTest1 that changed the security group. I can actually go ahead and view the change. They changed the security group. They added this security group and removed this one. And by doing so, they exposed this asset to the internet, and that's how they could even start the exfiltration process. And I see all the violations up here. Now, as a SOC analyst, I know how the attack started, I have the context I need, and I need to start thinking about the response. What's so innovative about Stream, because we understand what the environment looks like at every given moment, our response actually senses what options are available. So I can go ahead, I can go and click on the response button, And I see that I have different options. I can create a snapshot. I can detach this EC2 instance from the auto-scaling group. But in this case, I cannot do it because it's not applicable since it's not part of an auto-scaling group. So if you think about it, if you try to create your playbooks in advance, so you know what to do in case things hit the fan, you actually need to understand which operations are relevant. And only by understanding both the workload and the infrastructure, you can decide which activity or which response would be the right one for you. And I have many other options here. We're talking about this EC2 instance. So they're on the infrastructure level. I can isolate this instance. I can revoke it. I can do many different things. Now, we see in many cases that, okay, I can isolate or quarantine this instance, but maybe it's part of my production environment and I don't want to disrupt the operational resiliency of the organization. So I want to come up with more options to respond. And again, the goal of the context that CDR should provide is not just to detect and to kind of reveal the storyline, but also to provide as many options as possible to respond, so you can also take care of the actual business and not cause any disruption. If I go back to the attack storyline here, I see that the user that started everything, and we can see it also here on the timeline, is this URI test 1. I can go ahead and investigate this user. Now I see all the operations that this user has done, and I can start and understand first if this is the problem or this is the actual suspicious identity or entity in the cloud. So let's go ahead and do it. Here we see that this identity was triggered an alert because it was accessed from a Tor IP. So this is definitely something suspicious, something that we want to respond. And now I have two different touching points where I can decide if I want to respond on the EC2 level or on the identity level. So we saw that the EC2 instance was too complicated to respond. So I can use this response mechanism also on the user. And in this case, Stream suggests me to delete the IAM user access key, but again, it's not applicable because this user has no access keys. So I can go ahead and pick the right operation, again, based on the actual cloud state. So I don't need to run a new scan. I don't have to do any kind of troubleshooting or investigation. I know exactly what options I have and which of the options is actually available. Before I do it, I want to also check if this URI test 1 has access to anything suspicious or it's going to break anything in my environment. I'll go back to the inventory. I'll look for this identity. I found it, great. And I want to see which assets are associated to this identity. Again, this graph is real time. If there was any change, whether it's like security group change or an identity change, it's going to be reflected here on this screen. We had customers that told us that just to get all the association or all the dependencies per identity or per service, it takes them a couple of days just to find the right people to know that. That knows that. And here you can just, with a single click, go direct to all the dependencies, assess it way quicker, and based on that, make the right decision. I know we're talking a lot about Kubernetes, so we cannot do a demo without showing some Kubernetes stuff. So now we're gonna see another detection, and in this case, it's going to be part of a Kubernetes cluster, which was generated from our eBPF sensor. Again, I see that there was something suspicious. I can use also the AI to help me validate that and give me a better understanding of what happened. I see that a Kubernetes pod has been compromised with a reverse shell connection to an external host. And then the attacker accessed EC2 instance metadata to obtain credentials, and they use these credentials to access an S3 bucket. I'm going to investigate this issue. And when I see all the different operations, I see that, yeah, the sensor generated the alert of suspicious binary execution, but then I see the next steps. The adversary here leveraged a vulnerability of reverse shell, and basically they were inside the Kubernetes pod, and they did a reverse shell to access the CLI. And once they're in the CLI zone, again, it's a cloud conscious attacker. They don't treat this Kubernetes as just a random VM that lives somewhere. They understand that the cloud properties or the cloud configuration control plane is also part of the attack surface, or also part of their game. So they did a reverse shell. They got access to the CLI, and then they started to access the S3 bucket and start to exfiltrate the data out of it. And they also assume role to get more privileges and get the information out of this S3 bucket. Again, since I know what the cloud environment looks like, I can examine what it looks like on an active attack path. You don't need to scan, you don't need to jump between tools or use a CSPM that relies on static data. Based on our cloud twin, you see in live what happens in your cloud environment, where this pod is located, and what would be the next step for you while you're assessing this issue. I think it's definitely the AI capabilities that we see here are kind of table stakes. It's very easy to integrate and to add LLM on top of a solution like that. And I think where the real value is not just to apply the AI, but it really depends on which data you can enrich the LLM with. Because if you enrich the LLM with raw logs, again, like if you take the security group change example, if you just ingest into the LLM a security group was changed, there is no way in the world that the LLM will kind of extract or decode the downstream impact of this configuration change to understand that this instance is now exposed to the internet. Just there's no way to do it. And you don't really expect the LLM to log in into your console and figure it out. So the fact that every log that goes from your cloud service provider is not only being enriched, but is being assessed with its actual impact using the cloud twin brings so much clarity to our users. And we recently got feedback about the AI summary. They, instead of just sending all their logs to the SIEM, they just want us to send the AI summary, because the AI got everything it needs to assess like a human. It got the raw log, it got the downstream impact, it got all the correlation, all the correlated events. And by that, the LLM just makes the right decision. And again, an LLM will make the right decision once it gets the right data. And garbage in, garbage out, it's already a known term in AI and machine learning for a long time. And the key here is the accuracy and the enrichment of the data. Okay, I know I'm less and everyone is tired, so I think I made it in 30 minutes.